Hello and welcome to all students. In this lecture, we see about the functions and graphs of some standard functions. So this is BSc first year class, and today we are going to see about functions and graphs of some standard functions. Okay, so outline of our lecture is we see the definition of function, then some types of functions and graphs of some standard functions. Okay, so first of all, function from set A to set B is a rule which assigns every element of set A to unique element of set B. Generally, function f from set A to set B is denoted by notation f from A to B. Domain and codomain of a function. If f from A to B is a function, then the set A is called the domain of function f and the set B is called the codomain of function f. If x is a member of domain A, then f of x is a member of codomain B. If f of x is here f of x is called the image of x under the function f, or f of x is called the value of function f at x. F of x is called the image of x under the function f, or f of x is called the value of function f at point x. X is called preimage of f of x. Range and function. Range of a function. If f from A to B is a function, then the set of all images is if f from A to B is a function, then the set of all images in set B under the function f is called the range of function f. So range of f, it is the set of all f of x belongs to B such that x is in A. So range of function f is also known as image set of function f. So range of f is equal to image set of f. So range of f is always a subset of codomain B. Now we define the injective function. A function f from A to B is said to be an injective function if every image in codomain B has unique preimage in domain A. That is, whenever two images are same, their preimages are also same. Or whenever f of x1 is equal to f of x2, then x1 is equal to x2. In this case, we say that function f is injective function, or in other way round, we can say that whenever two images are not same, then their preimages are also not same. Injective function is also known as one-to-one function or univalent function. Surjective function. A function f from A to B is said to be surjective function if every element in codomain B has at least one preimage in domain A. Suppose f is a function from set A to B, then f is called as surjective function if every element in codomain has at least one preimage in domain A. In this case, we say that function f is surjective function. Or in other words, a function f from A to B is said to be surjective function if for any y belongs to B, there exists at least one x belongs to A such that y equal to f of x. If f from A to B is a surjective function, then image of f is equal to B. So image set of function f is equal to B set, whole B set or whole codomain. Surjective function is also known as onto function, and injective function is known as one-to-one function. Next is bijective function. A function f from set A to set B is said to be bijective function if it is both injective function and surjective function. So a function which is both injective as well as bijective, that function is called as, a function which is both injective as well as surjective is called as bijective function. Now next we define the composition of two functions. If f from A to B and g from B to C are two functions, then the composition then the composite function of two functions f and g is denoted by g composite f, and it is a function from set A to set C such that g composite f of x is equal to g of f of x for all x belongs to A. Okay, so here to define a composite function we need two functions. F is a function from set A to B and g is a function from B to C. Okay, both are functions. Then composition of f and g is denoted by g composite f, and it is defined that g composite f of x is equal to g of f of x for all x belongs to A. And g composite f is a function from set A to C. For example, let f is a function from set closed interval 1 comma 2 to closed interval minus 1 comma 1, and g is a function from closed interval minus 1 comma 1 to closed interval 0 comma 1. The two functions given by, or they are defined as f of x is equal to sin x and g of x equal to x square respectively. Composite function of function f and g is g composite f, and it is a function from set 1 comma 2 to the set 0 comma 1, and it is given by g composite f of x equal to g of f of x equal to g of sin x equal to sin square x. So g of sin x and f of x is sin x and g of x is equal to sin square x for all x belongs to 1 comma 2. Now we define inverse function. Definition: let f from A to B be a function g from B to a function g from B to A is said to be inverse of function f if g composite f of x equal to x for all x belongs to A, and f composite g of y equal to y for all y belongs to B. So let us see once again definition. Let f from A to B be a function g from B to A is said to be an inverse of function f if g composite f of x equal to x for all x belongs to A, and f composite g of y equal to y for all y belongs to B. Function g is called as an inverse of function f, that is G equal to F inverse. Function is said to be an invertible function if it has an inverse function. And then we define what is meant by a real valued function. A function f is said to be a real valued function if its range set is a subset of the set of real numbers. Okay, so this is all about the functions, and today we stop here. In the next lecture we will see the remaining part. Thank you very much.